Hi, I'm Leanpub from Leanpub, and in this episode of the Front Matter podcast, I'll be interviewing Barry O'Reilly. Based in Stockholm, Barry is a software architect with 25 years of experience. He has held chief architect positions within Microsoft, as well as being the global lead for solutions architecture community there. He is currently finishing a PhD in complexity science and software design. You can follow him on Twitter at TechnologyTulip and check him out on LinkedIn. Barry is the author of the Leanpub book Residues, Time, Change, and Uncertainty in Software Architecture. In the book, Barry provides an introduction to the subject of residuality theory, which he describes as a revolutionary new way to think about software architecture that fuses software engineering, complexity science, and philosophy to provide an entirely new way to think about the problem of architecting software solutions. In this interview, we're going to talk about Barry's background and career, professional interests, his book, and at the end, we'll talk a little bit about his experience as a writer. So, Barry, thank you very much for being on the Leanpub Front Matter podcast.
Yeah, cheers. Thanks for having me.
Thanks. I always like to start these interviews by asking people for their origin story. So I was wondering if you could talk a little bit about where you grew up and how you found your way into a career as a software architect and now doing a doctorate.
Yeah, well, I grew up in Belfast, in East Belfast, in Northern Ireland, during the fun times, I guess you could say, and I went to university, studied pure mathematics for no other reason than it was easy. I didn't like writing essays, so I came out of that degree. I didn't really know what to do or with my life. My entire class went to London, where you were, roughly the same time, to work in the finance sector, and I kind of stumbled into software because there were lots of openings, and it's kind of appropriate with that kind of background. I did that for a few years. Then I moved to Sweden, to Stockholm, in 2004. Continued working, took a master's degree in software engineering, and along the way I picked up a bunch of undergrad stuff in computer science as well. And then 2010, I went to Microsoft after having built a couple of platforms together with them, customers. I then did a lot of work with the concept of what is an architect, teaching architects, trying to get to the bottom of what is it that we do, and why is it so difficult to describe what we do. And I took a role there as the global lead for software architecture. And a lot of that work was teaching new architects, showing them this is what you need to know, this is what you need to do. And I had a sort of sneaky suspicion that when we told them this is what you need to read, this is what you need to do, and that was very, very different than what they would end up doing in the trenches. And so there's this theoretical disconnect from the practical side of architecture. And after I left Microsoft, I kept chipping away at that, trying to figure out, well, what is it that's actually going on here? And I started to look at my own process as an architect and be honest about it and say, what is it that I do when I go to a client and listen to them and build a software solution? What do I actually do? How do I get there? I know that I get there, but how and why do I get there? And why do my colleagues get there? And why do some people never get there when they're trying to do this? What's the difference in us? And I started to realize that among those of us who were able to deliver architecture at that kind of level, there was a much easier approach, or a much more relaxed approach to uncertainty. That senior architects were able to sit down with clients, listen to them. The client didn't know what was happening, didn't know how their own business was going to work, didn't know how their market was going to play out, and very few do. That's the nature of business. But some architects were able to take this and still build something based on it, whereas a lot of architects would freeze up and say, well, I can't build something if you don't tell me what it is, or how this thing works, or how this business works, or how this future is going to look. And that led me to doing some reading on what is uncertainty, how do we deal with that? And I discovered then the complexity sciences, which were a whole treasure trove of hundreds of years of ideas around how do we cope when we don't know what's going on. And that led to me start to formulate some ideas about what is it that actually happens when we do architecture. And that led to publishing a couple of academic articles. And I published them first in enterprise architecture journals. They got picked up, and someone said this should go to an academic journal. And that led to me starting a PhD program in complexity science and software engineering. And I did a couple of talks on this, and I did some work with the Swedish Computer Society on it. And, people said, you should this is a big idea. You should take it further. So I started this little company just to drive this idea at the same time as I was doing my PhD. So I think one of the things I've done, which I think is kind of, well, it's maybe not unique, but it's not something you see so often, is that I turned the entire process of getting a PhD into a business model in a way that's worked out incredibly well for me. And that was quite a few years ago that I started to work towards this. So I'm now polishing up that PhD and spending a lot of time teaching and talking and writing about these ideas. And what I've done is, in the last couple of months, I've been putting together the first drafts of my final thesis. And I got a call from the organizer of a big software conference who said, it would be great if we could get a link booklet about your ideas that we could give away to all the participants at this conference. And I said, well, I'll see what I can do. And I put that little booklet together. And then I realized that if this is given away free at this conference, people will talk about it. And lots of people will email me and say, can I get a copy? And so I thought, I might as well publish this thing ahead of time so that it's already there, so I can just give them a link. And that's where I'm at today. So I've just launched this book last week, and this little booklet, and the ideas are, I've been touring this a lot. I've been doing this a lot, speaking at a lot of conferences across Europe on this, and the ideas are starting to pick up, a bit of hype, but people are spreading them and talking about them. So
yeah, thanks very much for sharing.
Pretty cool time.
Yeah, thanks for sharing that really great story. And I'm so happy to hear about this sort of momentum that you've been building, that's sort of happening now, that you've been building for so long. And for anyone interested, you can find Barry on YouTube. One of your videos, I believe, recently got more than 10,000 views, which for the subject of kind of software architecture and complexity theory and philosophy is a lot of views anyway. But it's a really compelling idea, and your talk is very compelling as well. And I'm really looking forward to talking about diving into some of the ideas around complexity science and philosophy as well. But before we do that, I wanted to you mentioned earlier on that you studied pure maths, and you picked up kind of programming along the way. And you've studied in a number of places, but one of them is the Open University, which I believe is where you're doing your PhD.
It is, yeah.
And I just wanted to take the opportunity, because since we talk to so many people from all around the world on the podcast, and they have all so many different backgrounds, I don't think I've had a chance to talk to anyone about specifically the Open University and what an amazing institution it is. So if you could talk a little bit just about what it is and what it's like doing a PhD at the Open University, I think people would be really interested to hear about that.
Yeah. So for the choice of where I was going to do my PhD, I wasn't really sure, and I talked to a lot of universities across the world, and I talked to a lot of sort of very well-known schools. That's why, hey, well, should I do this at one of these fancy schools and get that sort of stamp? But I ended up going around the world a few times, talking to different potential supervisors. And what I'm trying to do is so broad. So I'm doing a big chunk of this is philosophy. There's math in there, there's complexity science, but there's also programming and software engineering. And trying to find someone who was even willing to take on that, especially, as I first moved into my PhD, I maybe wasn't entirely coherent the whole time, bouncing around between so many things. And the reason I went to the Open University was because of my supervisor, Jeff, because there was a mathematician who had written books on complexity science, and was very interested in design and innovation, and had some software experience as well. So it was almost a perfect match. I had studied with the Open University before, My master's level stuff was done there, and I found for me, I find conventional university incredibly boring. It just went way too slow. And so a pure math degree is 18 modules over 3 years, and could have been done over 6 months, because you're just doing the same thing over and over again. And so the Open University allows you to work at your own pace, and my pace is frenetic and then quiet for a long time and then frenetic. And a classic university have time for that. They want paper every Friday and they have regular lectures and things like that. And the Open University would have suited me much better even when I was young. But as an adult with a family and a job, it suits me perfectly. They've got, I find that their teaching has a very high standard compared to conventional UK red brick university. And the support you get there is absolutely fantastic. But it's mostly for me about the freedom, about not needing to be tied to a particular campus. But again, 99% of PhD is about your supervisor, and that's what brought me to the Open University. When I talked to the Swedish universities, for example, the only model they could offer me was to work as a full-time PhD student, which is a salaried position here, but in Sweden. But the salary is not something that a software engineer could be comfortable with. So I didn't want to give up 5 years to do that. So that's why I ended up in university. It's been so far an absolutely fantastic experience. But I would say that with that, I'm a very independent PhD student.
And do you have to do any courses or teaching or exams as part of the PhD there?
No, it's a pure research PhD, so it's by publication. So the only thing I have to do is publish a PhD thesis. And so halfway through, they make you publish a little mini thesis and defend your idea and show them that I have actually learned how to research and that there's depth to this, there's meat on the bone. So it's a kind of examination that you have to pass to show that you're on your way towards something. In terms of courses, I can just call my supervisor and say, the Open University has hundreds of courses, and say this undergraduate course on epistemology, I need those books, and they just come in the post, which is fantastic. So you have access to all of those courses if you need them.
Yeah, that's just so amazing. It's interesting. We were talking before. I did a doctorate myself years ago at Oxford, and Oxford has a similar approach to doing a doctorate, which is like, there's going to come a point when you don't need to take courses and exams anymore. This is the point for you now. Write a big research project. And there's this sort of people who've never, done a PhD might not know that there's the kind of little bit of a, conflicting idea about how to do it between the sort of, I'll call it the North American model and the kind of the model that we're describing. If you're thinking about doing a PhD in a North American university, you're going to have a couple of years of courses with exams, and you're going to have a big set of exams that you're going to have to do. And then maybe you might be kind of like working on your doctorate and call it ABD, or all but dissertation at that point. And they're very different models. They're suited to different people differently. I mean, my joke about like Oxford, which is the same as yours, is like, you do have at least I might be dated in my terminology, but you were in probationary status for your first year. The end of that year, you had to submit a paper and an outline and stuff to sort of prove that you can do stuff. But more or less effectively, you, as you said so well, the most important thing is your supervisor, finding someone at the cutting edge that you're on, appropriate, which might involve looking all around the world. But second, what they do is my joke is like, they kind of reel you out like a kite, tie you to a rock, and come back in 3 years, and they're like, hey, have you done anything? It's sort of like, that's the maximal freedom kind of approach to it, which, so to some people, that's like exactly what they need and want. I would totally appreciate what you said about sort of frenetic pace, kind of quiet time, frenetic pace, quiet time. Typically North American university model is very much more structured. You'll have believe it or not, for anyone who hasn't gone through it, you'll have like a committee of people who actually pay attention to you and monitor your progress. and things like that. And it's one of them. I mean, next. I mean, it's sort of hard to compare them, but like next to choosing your supervisor, choosing between those two models of PhD is the most important choices you're going to make.
Yeah, yeah. I can see that even in the UK, with certain PhDs, especially in the hard sciences, they're more led by the hand. It's like, put on your lab coat, press this button, write down the numbers, and write a story about why the numbers turned out the way they turned out, and it's much more guided, maybe not with formal courses. Whereas the particular model that I've been working with is just pure freedom, which is absolutely what I needed, because this thing took a lot of twists and turns. It didn't go in the direction I thought it would, which has made it much more fun.
It's so interesting. You're reminding me of the college where I lived when I was in Oxford. I had lots of friends who were in the sciences, and their life was just so different from mine. Like mine was like, I'm going to stroke my chin until 4 a.m. and get up at noon if I want to, and theirs was like 8 a.m. at the lab. I booked my supercomputer time, better be there for that. I've got an experiment running, things like that. And it's just such a very different approach and different kind of work. But just moving on. So there's just so much to talk about, to talk about your book. So why don't there's two things we need to talk about, I think, before we sort of get into the book. One of them is what's software architecture, and one of them is what's complexity science. So maybe let's start with what's software architecture, if you can talk a little bit about how you define that in your book.
Yeah. So in the book, I've defined software architecture simply as the role where we define the structure of a software application, the relationships between its components and its environment, and how it behaves in its environment. So we build a structure so that it behaves in a particular way. And when we talk about behavior, what I mean is a software application will have a function. So you go and you click on a button, it updates some field in a database somewhere. And that functionality is most of the time fairly trivial. And it's not really that interesting from an architectural perspective. And that's what programmers do. That's what developers do. They build functionality. The architect is concerned about the behavior of the system, which is, how does it work when it's got way more users than it was built for, or way less users than it was built for? How does it hold up when someone's trying to breach it or break into the data stores or affect it negatively in some way? How does it work when we need to change something drastically in the business model or the surrounding environment? And so I call that in the book the system's behavior. And the architect's job is to create a structure that gives us a behavior that allows the system to live for a long time, and with a high degree of quality. And that's what architecture is. As I say in the book, there's as many definitions of architecture as there are architects. And this is something that leads to a lot of debate, but it's simply that's what it is.
Yeah, no, that's really great explanation. So a lot of people will think about a programmer. It's like, create a button that lets someone sign into an account or something like that, or sends them an email that says, click this link to sign in or something like that. That's what the programmer does. What the architect is doing, just at the very broad level, is like, what if 1 million people try that at the same time?
Yeah.
What if 1 million people try it at the same time and enter the wrong email address for their account? What if someone's trying to, anyway, that's sort of the very, very broadly, you can think about what happens if there's like a denial of service attack or something like that, and things like that. And it can get very complicated and things like that. And it's just a sort of fascinating thing. But so now that we've got that there, then the next thing is complexity science. And can you maybe talk for a few minutes about what that is? And again, it's one of those things where like it's, everybody's got their own definition, but.
Yeah. So complexity science is the study of, in my definition, and I think this is also the definition of an Italian physicist whose name I can't remember, but complexity science is everything that's beyond the reach of our conventional science. So if we can't explain it, if we don't understand it, if we don't understand the mechanisms involved in certain things happening in the world around us, then it belongs to the domain of complexity science. And within complexity science, and there's a bunch of different schools of thought, people who look at these things from a mathematical perspective, and they map networks and and look at those things and graphs. And there are biologists, quite a few biologists, who are trying to answer the question of how does all this happen? How does life come to be? And physicists who are trying to push beyond where we've got with conventional physics, with Newtonian physics, to say, how do we explain these things that are outside of that domain? And there's also anthropologists and a lot of management science people using the same ideas and techniques. And there's a core body of literature that we all read, but everyone has their different focus and their different perspectives. But it's really about answering the question. For me, it's about answering the question of how do we cope in an environment where we don't have anything to fall back in, where we're not in control, where we don't know what's going to happen next, and we can't potentially control what's going to happen next. And one of the things that I had to define to make this project make sense was what kind of system is a software architect working with? And software is, by my definition, and this upsets some people, software is not complex. It's actually a very, very simple thing. A software system will not do anything that it hasn't been told to do. It's just bits and bytes, and those bits and bytes don't have any ideas or ambitions or projects. They're just flowing through a piece of sand, and we constrain them greatly. And the systems that we build, the software systems that we build, are very, they're complicated. There's lots and lots of pieces. It takes a bit of time to understand how they work, but they're determinist. They're determined systems. They're predictable. They're mappable. They're testable. And we can make, if you think about banking or trading, we can make a system do the same thing trillions of times and understand how it's worked with very few exceptions. And so software and the way that we're trained to write it and think about it and build it belongs very much in this world of ordered systems, where mechanical systems, where we have efficient cause, where if A then B holds, and there's a relationship between cause and effect, and it's an engineering world. And the problem we have as architects is that once you've built a little piece of software, you've designed it, we take it and we place it into a business context. And the business context is full of people and groups of people. We call them companies, I guess, and markets and societies, and there's politics and there's economics, and there's all these things happening, and everything is moving at the same time. And those systems are disordered and complex, and they can't be studied in the same way that we study software. And, if you try to apply pattern approaches to them, you get into trouble because patterns don't hold over time. If you try to write down everything that's happening in one of those business systems, you'll never be finished. And by the time, even if you did by some miracle manage to write down all the details, they would have changed by the time you got there. And the thing that makes software architecture unique is that we take this ordered system, it requires that set of engineering skills that we all learn at college, and we put it inside this complex moving system. And I give this kind of system, this ordered core and this disordered environment, I call this a hyperliminal system, because we're constantly moving between these two worlds. And if you're a software architect, you've probably only been taught how to do the bit in the middle. That's the only thing they teach us at college. The rest you have to figure out by yourself. And that means, and we figure that out just by jumping off the cliff like lemmings. And, some people survive, some people don't. And some people get to work with interesting projects, and some people get to work with boring projects. And we all have different perspectives of how to manage this constant back and forth between the simple ordered thing and the chaos around it. And one of the things that tends to happen is that the engineer, because we're trained as engineers, we're trained as basically a kind of mathematician. When we look out into this disordered world of the business, we try to order it. We try to make it look like our world. And so we draw lots of lines and boxes, and we try to make it simple, map processes and organizations, and come up with very structuralist ways of understanding the environment that our system works in. And so what we do is we treat the world around our machine as a machine, which tends to get us into trouble as software architects. And so the complexity sciences gives us a way out of this, a different way to think about that disordered system. And then that brings us back to thinking about very much as an architect, the relationship between the disordered system and the ordered system, how that one pushes the other around.
Yeah, it's such a fascinating topic, and just to give people a little bit of flavor of it. Do you know the theoretical physicist Sean Carroll? He's got a podcast called Mindscape that's just really, really fun and good, and he interviews theoretical physicists and jazz musicians and all kinds of different people. But he does a similar move to what you do when he's talking about theoretical physics, and he says it's really easy. And sort of when you say sort of software is kind of simpler, you're saying it in the same vein. It's that it's not an insult. It's a recognition of the different quality of the problems that are dealt with when you get to the level of complex systems. So when you get like groups of atoms interacting and groups of people interacting are just completely different kinds of things. And one thing you're getting at that I really appreciate is that like a lot of us just desperately want that world of people to act like that group of atoms. If you want to know why most economics is complete bullshit, it's because it's like, and this is my opining here, it's because people are just like standing on their head, doing whatever they can desperately to get away from the fact that you can't do science on people, complex systems, the same way you can do science on like collections of atoms. You just can't. A lot of us, existentialist philosophers would have their own explanations of why people repress that fact. But like the really fascinating thing about your work is you kind of tie that mistake into why big software projects fail. Because we hear about this all the time. We've got a big one in Canada right now with like what ought to be not that tough a problem, which is a payment system. And yet like billions of dollars can be spent on software that doesn't work. And why does this happen? And one of the reasons is that if I'm to sort of like, try and put words in your mouth, is that like people desperately want to be able to use these sort of ordered systems approaches on things when they don't work at the level of complexity.
Yeah. And that's very much a problem that we see across the entire industry, is that we're trying to order these disordered systems as if they were circuit boards, as if they were software components. And this has its roots. It goes all the way back to IBM had a program called Business Systems Planning in the late 1960s, where they first started drawing organizations as lines and boxes. And the same lines and boxes that they were drawing to describe the circuit boards that they were building for their computers. And this idea of the mechanistic organization has been with us for, and if you go back to Viner and Stafford Beer and the cyberneticians, they were looking at the organization as a machine, as a set of feedback loops. And we've been trying to find a way to treat organizations the same way that we treat software or any engineered system for a very, very long time. And so that bleeds into all our modern software architecture practices. And if you look at, you mentioned economics, and so economics bleeds into the MBA programs. They're trying to do exactly the same thing. And enterprise architecture, which is kind of the business level of architecture in most organizations, have borrowed the thinking of the MBAs. And so the whole thing just feeds itself. And you've got this army of people who try to control the disordered side of the system with lines and boxes, which inevitably break and shatter as soon as they have any contact with reality.
Well, and that's interesting. So I was hoping to find the right moment to bring up philosophy, but when you're talking about lines and boxes and objects and things going, like the roots where these go back to is actually you would claim partly in terms of our thinking all the way back to, say, Plato.
Yes,
where we start thinking about things in terms of objects rather than, processes or systems.
Yes, there's a very definite undercurrent of Platonic thinking in software engineering, and one of the things that I found, and one of the twists that my PhD took, was that I was just going to run these mathematical models, do some complexity stuff, and then say this is why this particular phenomenon turns up in our software systems. I started to realize that the way that we were thinking about things was completely wrong, and that what Plato tried to do was to describe these abstractions, these forms, these perfect things that live in some heavenly realm, that somewhere there's a perfect person, and we're all just sort of copies of that simulacra. And if you look at how software engineers think about the world, you look at their software systems, you'll find, in most systems, you'll find a customer object, and that's the perfect customer. And that's created as a thing called a class, and it will execute as an instance somewhere inside the software system as a little copy of this perfect class. And so those Platonic ideas where what you do is you argue until you get to the point of a perfect customer object, and these abstractions are the right result, is the way that most software engineers try to describe the world around them. And this is called essentialism. So there's an essential form to things, and you can group them. And when you apply that essentialism to complex systems, which obviously have more than one thing, then you can't just talk about the essence of a system. You have to have something else. And the essence becomes the structure of the system. And the software architect and enterprise architecture in particular get caught up in describing these structures of business systems. And that's why you get the lines and boxes, because they're trying to, what are the things and what are the relationships between them? And one of the things that I had started to do in my own practice without realizing why or even thinking about it was that I didn't trust any of these structures that we were building, because what we noticed is, and the Agile movement noticed this over 20 years ago, those structures crumble on their first contact with reality very, very often. And so what I had started to do was to build my architectures around the crumbling of the structure rather than the structure, because the crumbling was inevitable and the structure was always wrong. And so from my point of view, the most interesting thing about the way that we model systems, the way that we think about business systems, is the way they fall apart, because they always do that. And you can be guaranteed that they'll fall apart. Whereas the industry is focused on making them correct. And that's the programmer mindset, coming in and trying to get this correct answer to what is customer. Whereas in my world, customer is this constantly falling apart thing. It's always changing and always moving. And that links to the work of philosophers like Deleuze and Bergson and Whitehead, who talked about Derrida, who you probably are familiar with. Their view of the world is that one of a collection of processes constantly moving, and as those processes interact with each other, as things are constantly pushing, shifting, and changing, from my perspective, then they leave something behind, and that something behind is what we look at and we fix on and fixate on, and that what gets left behind is the residue, it's the leftovers of the thing. And so my perspective is that when we try to grasp an idea, like a customer or an order or a product, what happens is that we build a structure, because that's what we're instinctively seem to try to do, which is what Plato talked about. And that structure will feel, and as it feels, then we'll need to build a new structure. And when it feels, it'll crumble, but there'll be a little bit left over. That's the residue. We build on top of that residue to build a new customer, and then it crumbles, and we build another piece on top of that, and maybe it splits and it changes. And as a software architecture, then, where we normally describe a software architecture as a set of components and their relationships to each other, which is very static and very, very vulnerable to that kind of changing world, instead of trapping ourselves in that static picture of the architecture, we describe our architecture as a set of residues, which correspond to these crumbling sort of mental structures that we have for the business environment. And when we map those two things together, then we have a fighting chance of expressing the kind of change and uncertainty that exists in these business environments, but still keep it linked to the actual structure of our software.
One of the really great things about this idea of residue or residuality is that it actually allows you to give very specific examples. So a lot of this stuff, there are levels of, there's this sort of I don't know, kind of fancy stuff around complexity and philosophy and stuff like that. But like you'll say, like, but here's the idea, right? Here's an example of a residue and what happens. And I know you've done it in your talks, but it's just such a good example, the one you give of electric vehicle charging station.
Yeah.
And I was wondering if you could just, go over that example, because it sort of shows very concretely what this means in both the physical and software programming sense. But like what a system's humming along, and something hits it, and it changes, and there's this residue that's left of the system. And so maybe if you could just go over that example.
Yeah. So the thing that I started investigating in my PhD, and the thing that I thought was curious, was that in my own practice as an architect, I abandoned everything that I'd ever been taught, and I built up a set of very, very simple practices that allowed me to build, very elaborate systems easily and without a great deal of ceremony. There's a lot of ceremony around architecture, so getting rid of that has value in itself. And what I realized that I was doing to my systems was that I would immediately come up with a structure, come up with an architecture for that structure, and then break the structure and watch how the architecture broke, and continuously break it. And when you do that, as I explained in the video, you reach a point in your architecture where you reach something called criticality, and that is that the architecture has been pushed around so much that it takes on a new structure, and that structure starts to survive things that it wasn't built to do. And you'll find this idea in where I talk about the biologist Stuart Kaufman in his work, where he talks about how this point of criticality is reached. You'll find it in the work of Nassim Taleb, who you might be familiar with as well, who talks about the concept of anti-fragility, where something gets strong because it gets pushed around a lot. I realized this is what I was doing in my own practice. And so to go back to the car charging example, we build a really simple structure. We say, well, cars are going to drive up, they're going to log in, we're going to let them charge. And that's our simple structure. We start off with that. And then we bully it, and we say things like, yeah, that's our current structure today, but what happens if there's a different kind of electric car? Or what happens if there's a failure in the electric car market? Or what happens if there's a completely different kind of battery, for example, that is invented and requires a completely different kind of infrastructure? And so as you stress the system, you reveal a residue, and you see that this system, this architecture, is weak in this particular, it's sensitive to this particular kind of change. And you look at it and think, how can I make it less sensitive? A lot of the times you make it less sensitive just by moving component boundaries around in a way that doesn't really cost a great deal. And then you stress it again, and you move those component boundaries, you stress it again, and eventually you'll see a behavior where it starts to stand up on its own, kind of like Bambi, and it starts to survive things that weren't in the specification, that no one told the system about. And in the example of the car chargers, one of the things that stresses the system is that we can't log in. And so we change that, and we say, well, let's not log in. Let's have a different way to log in. And let's log in by reading the license plates.
Yeah. So just to jump in there. So this very specific example, which I just loved, is like, so you design it, you put up a car charging installation, and people have an account, and they've been mailed a fob, and they can drive up to the charging station, and they can, show the fob to the machine, and the machine goes, checks and goes, oh yeah, you've got an account, we can charge you now, and then you can use the machine. Well, what if the fob doesn't work? Then you're like, well, let's get this. So the residue now is, to be very specific, in this case, is a car sitting there in the way that can't, with an unhappy customer in it. So this is a very concrete example of residue. You built this whole system, it was working, and then boom, a fob that doesn't work. That changes the system, and now you've got here this residue that you perhaps, I mean, in this case, that one might be kind of predictable, but there's all kinds of unpredictable ones, like people protesting against the electric vehicle as a technology by parking their fuel car in front of the station to prevent people from using it.
Yeah, and so in the example I gave, this phenomenon called icing, where people start to park their fossil fuel-driven vehicles in front of the chargers. That's one of those things that, as a software architect or as a requirements engineer, as a business analyst, you don't catch that kind of variation. You don't catch that possibility because you're not looking that broad, and it's impossible to predict those kind of weird social behaviors. But in the example I gave, because we'd stressed the architecture from a bunch of different points, it had enough flexibility to be able to cope with that thing without being told or without specifically being built to survive in that particular place. And that is something that Kaufman predicts with the idea of criticality, something that Tala talks about with anti-fragility, and it's something that as you stress an architecture, and this is the basis of residuality theory, as you stress an architecture and fix the sensitivities in those stresses, it takes on a structure that eventually will be able to survive. And from complexity theory, this is how biological or economic or political systems survive for a longer period of time. And whereas in the past, software engineers have tried to be rigorous and rigid and say, this is the correct answer, this will run, what I'm saying is that we need to move away from that rigidity and move towards this criticality, to architectures that are able to survive some of the things that they haven't been designed for. And that's very much the perspective of the entire software industry right now. Anyone can build the requirements. Can you build a system that will keep running whenever an unknown future suddenly unfolds? And this gives architecture a kind of renewed goal. As opposed to just drawing lines and boxes. Now we have something to fix. We have to aim towards this criticality. And it's something that, as you see in the book, you can show mathematically that you've actually made this happen. You can do a calculation and say, I'd made this system more likely to survive unknown unknowns, which is a big step forward for the software industry.
Yeah, I know there's a very, I don't know, kind of what's the right word, like sort of deep and subtle point you're making there, where, so you mentioned Bambi, and so you use that gives me the example, gives me the opportunity to bring up Godzilla, of course, which is, one way of saying, like, if you're working on a team and you're like, we need to stress our system, we need to apply these ideas. Let's imagine an attack by Godzilla on our system, metaphorically or even practically, but like this means like we have to prepare for flood, we have to prepare for earthquake, we have to prepare for fire, we might have to prepare for King Kong coming down too, and there's a couple of reasons this is such a brilliant idea, at least from when I learned about it from watching your videos and reading your book, is that what it means is that you are sort of testing randomly. So, and in the sense that it's not some sort of predetermined, we're going to test this, and then we're going to test that, and we're going to test this, and we're going to test that. It brings in that idea, but it also, what you're doing is sort of like, there's this unity of form and content, right? Because in order to introduce these ideas into the human system, you have to take the human into account. And if you ask people what to test, they're going to tell you the things that they know how to test. Yeah. Like they're not going to admit to the things that they don't know. And so there's this very subtle point that's being made by using this practice of bringing in Godzilla that I just found so kind of fascinating about what you're up to with residuality theory.
Yeah, and it's very much about the fact that when we try to predict what's going to happen in a complex system, we can only touch a tiny fracture of it, and our predictions can never be correct. And the way, if you look at how evolution handles this, or natural selection, the way to do it is with randomness, is to randomly simulate an environment, and eventually that will bring you to a point of criticality. And that completely moves the goalposts. And this is something that then becomes very, very difficult for software engineers and architects to understand, because now they have to very much move away from that old philosophical view of the mechanistic world. And suddenly, it's much more biological, like Bambi. It's like, and so we're not designing software anymore, we're in training it. We're forcing it to a position of survival.
And it's interesting. I can tell from your videos and stuff that you're sort of battle hardened, right? Because like a lot of people, when they hear this kind of thing, they think it's kind of woo woo, kind of spiritual or something like that. And it's like the brilliant example you give. At least this is how I interpreted it. What you're up to with it is, let's say you've got a circle, and you want to figure out what the area of the circle is. You can surround the circle with a square. So it's the area of the square is x squared. If one side is x. Now, when you ask people, if you show them the diagram of the circle and the square, and you say, how are you going to calculate the area of the circle, people are like, well, tell me the radius, because then I can do pi r squared and I can get the radius. But there's another thing you can do, which is throw a million darts at it. And if you can know when a dart lands at the square, whether it's either in the circle or out of the circle, and if you threw a million darts at it and 500,000 were in it and 500,000 were out of it, you'd know the area is x squared over 2. It's half. And this is a rigorous result, but it's based on random testing, not on the application of a definite formula.
Yeah, and that's the shift that has to happen for us to understand that to deal with complex systems, it's not about finding the formula. It's not about gathering the perfect requirement or the perfect object or the perfect set of structures. It's about randomly simulating something until you get the behavior that you want. And that's a huge shift. And one of the issues we have in our industry is that we have lots and lots of talented architects who can build good architectures. And they figured this out. They figured out this is what they do. And a lot of very senior architects have said to me when I show them these ideas, this is what I do, but I've never had it explained to me in this way. There's a paper from 1986 that I referenced in the book by a guy called David Parnas, who says that look, there's no rational, structured way to deliver software. It's just not possible. So we knew very early on that it wasn't. But he says in this paper, and this is one of the most respected researchers within software engineering, there's great value in pretending to management that we do know what's going on. And we've been bluffing for 40 years. And it's time to say there is no rigorous way to do this. Random simulation is the best way to generate a software architecture. And that goes against everything that the industry was taught. Software engineers who are coming out of university, this is not what they've been told. It's all about precision of language, things like that.
Yeah, there's a I don't have a name for it. Maybe hopefully someone else has named it, but there's a certain kind of like trick we play on ourselves or mistake we make where we kind of like, if someone says, no, you'll never find a four-sided triangle, they're like, we just need to keep trying, or you haven't tried hard enough, or you don't understand the problem properly, or you're just giving up. And it's like, no. And it's specifically when you say, like, for example, there's a certain kind of person, coming from finance, who will say, like, give me the numbers, show me the data. And it's like, you're hallucinating. You're hallucinating. And when you tell them there's no, like, that would be misleading to give you the numbers. That would be misleading to give you the data, because what you're looking for is that formula for something that doesn't have one or shouldn't be approached that way. And that's so hard that there's just this reflexive mechanism that people have that, like, you're just giving up on the problem. Eventually, we're going to find the formula that explains all human behavior. Eventually we'll find it. And it's like, no, we're not giving up when we say you can't do that. That's just not the nature of the problem space. Yeah.
And so one of the things I've said in the book is I've described how the software engineering industry has been on a journey, and we've had our own structures, that we've built to say, this is what software engineering, this is what architecture is. And those structures are crumbling. As they crumble, we add new things to them. And over time, we're getting smarter and smarter. As though I see this as the next step in let's change the way we look at things completely, instead of just trying to go down that one avenue that we've been trying for since the 60s.
Yeah, it's just so I can't stress enough for anyone listening. It's so important. Like, we're not just talking about the app on your phone. We're talking about how the whole world works, which is basically software based now.
Yeah, exactly. And the nice thing about it is, if you don't care about the complexity science, you don't care about the philosophy behind it, if you're just a software engineer and you don't want to read any of that fluff, it's a couple of Excel sheets and a couple of exercises that make sense and that will make your architecture stronger. And if you don't want to know how or why it works or why it's related to the struggles between continental and analytic philosophy, you don't have to put any effort into that. You can just build it.
That's something we talk. Sorry, go ahead.
Yeah, one of the things I think is exciting about it is that in the last 20 years, the concept of architecture has lost a lot of credibility, because it doesn't deliver generally enterprise architecture. And there's an entire generation of younger software engineers who don't want anything to do with architecture. And I've been able to talk about these ideas at software conferences and reconnect with these younger engineers who say, oh, this is an architecture, this is an idea we can get behind. There's something going on here that's different than the previous generation of architecture and enterprise architecture. So hopefully this will in some way move the industry forward.
Yeah, that would be great. I mean, it's crucial work. I can't help but say, so for anyone who just heard about this distinction between the kind of like continental and analytic philosophy, it's a wonderful realm to explore there. If you were looking for one place to start, there's a philosopher called Husserl who wrote basically a large pamphlet called Philosophy and the Crisis in the European Sciences about 100 years ago. Check it out. Try reading it a couple times. But there's a very important kind of thing going on in our intellectual tradition and history that Barry's bringing up there that we probably shouldn't bother going into right now. But there's a lot to explore there, and it's very important about basically our theories of knowledge about the world and how we talk about them. And that's the thing that pisses off the analytic guys, is that the continentals are willing to talk about things in ways they don't like, and they'll fool themselves into thinking that what's happening is like the continental people are being unclear. And it's like, no, that's profoundly naive. They're not being unclear. They're being very clear in the very precise way that they need to be by using language the way they do. That's my little rant.
One of the interesting things was last year, as I was writing the chapters on my philosophical position, which is a very unusual thing to have to do when you're in the sort of close to the mathematics department, because it's all settled there. I put together a couple of short online courses for engineers called The Philosophy of Software Architecture. And I thought this will be fun. A few people will turn up, and we'll talk about how philosophy impacts and how it can be used to change how we look at the world of software engineers. And both of the courses sold out. So there's a hunger out there for this kind of thinking at a certain level in the industry, which is very encouraging.
Yeah, definitely. That's very. I'm very glad to hear that. Just moving on to the last part of the interview, where you talk about your experience writing as a writer. So you're doing this academic work, that takes years and stuff like that. But your book is a pamphlet, and it's the result of a lot of work over a lot of time. I was very interested to hear that origin story of the book, that it was actually like in anticipation of distributing it to people attending a conference that you were asked to write it, because this is something we encourage all Leanpub authors of nonfiction books to do, is once you've written your book, if there's a conference on the topic, offer it to them for a big batch discount, something like that. But you did that in the other order, which is just fascinating. And so how did you go about writing the book? Did you distill things from your thesis? Did you have blog posts, or how did you go about writing it?
Yeah. So I started writing about 8 years ago with the first sort of journal articles that were the seeds towards these ideas. And if you go back and look at the academic articles I published, I think there's 7 or 8 of them, you'll see the idea being built up over time. And every year I would add new layers to it. And that was a fairly torturous process, because as I said at the start, I chose pure mathematics because I don't like writing. So the first articles, my wife is also a PhD. She said, you can't write. Think about it like this: do this, shorten your sentences. And what I did was then I'd give it to her, and I would say, does this make sense? And then I would get another friend doing a PhD, and I'd say, does this make sense to you? And over the course of 7 or 8 articles and a whole bunch of other sort of commercial articles that I wrote, it built up a little team around me. And every time I wrote something, I would just send it out. We'd go around and it would come back, and everyone would say, well, this is crap. This doesn't work. And your sentences are too long. And I did I wrote some papers for a journal in the US called Cutters. And I got a professional editor there who's called Cindy Swain, who was really, really good. And she would, teach me things like, you need to move your last paragraph to the start and stop building up these big stories and things like that. And then as I got better at writing, I got credit for what I was doing and on the academic level. So my professor, my supervisor would say, your writing's gotten much better. But developers would say, we can't read this. And, when you're writing articles for a journal, you've got 7 pages, you've got a lot of things you have to get in, and it's really, really dense. And so the plan was to finish the PhD thesis and then make a more civilized version for the rest of the world. And so that's what I was working on before Christmas. And I got the call who said, we'd like to put this out as a booklet. And I thought, maybe I can kill 2 birds with 1 stone and use the same text. Then I realized that no, it's not going to work because people don't want to read this heavy academic prose. And so the book that's on Leanpub at the minute was actually written in 1 day. I woke up and I was stressed about it. And I was in Munich and I was flying home, and it was a connecting flight because there was a strike. And so I had 12 hours sort of sitting on planes, sitting in airports. And I had just took my phone and I just wrote constantly. I deliberately tried to write as simply as possible and take away all the big words that you'll find in my academic writing and make it as simple as possible. And then I sent it back out to the same group who've been helping me for years. What do you think of this? And the feedback came back. It was like, wow, you finally learned how to write for humans. So that was the process that led to this. I would never have happened if I hadn't been asked to write a shorter, sort of more concise text. And it is a very, very different style to what I normally produce, which is heavy academic prose, heavily referenced and lots of technical terms. And so I had to keep the math out and keep as much of the philosophy out as possible, but still tell people that it was there somewhere.
That's a really great story. When it comes to how long did it take to write it? It reminds me of a story of a friend of mine's dad who's retired in his 70s. He's been painting since he was young, and someone once asked him he just finished a painting, and I think he did it in a day. And someone asked him, how long did that take you to paint that? And he goes, well, 50 years.
Yeah.
You can't break it down specifically. And there's also the sort of inspiration hits you or constraints and stuff like that. And so that's just such a great story. And it's such a good book as a result. The last question I always ask on the podcast, if the guest is a Leanpub author, and I save it for the end because maybe no one's interested except the author themselves. But if there was one thing on Leanpub that we could build for you, or if there was one thing that had you shaking your fist, damn you Leanpub, that we could fix for you, can you think of anything that you would ask us to do?
I think I haven't actually had this thought before, so you're forcing me to it. I like the way the platform works. It works perfectly for the way I write, because I've already got a couple of new chapters in my head. I think maybe I'll go and put those in. But the one thing that's difficult for me, everything is there. And that's what I liked about it. And I talked to some other publishers, and I wasn't particularly enamored with the idea of going with a traditional publisher because of the rigidity of the entire thing. The one thing that's really, really difficult for me right now, when I've written the book and published it, is how do I get people to know that it's there? And I guess this is what we're doing now. How do I push this out? And so, through my own social media channels, on the first day of release, I could drive a huge amount of people towards the book. But social media won't let you do that forever. You can't keep publishing the same link. And so the one thing that's missing for me is some way to make the marketing of the book easier.
So yeah, that's a great question. I mean, you're basically asking about what's the hardest thing. I mean, other than writing the book in the first place, the hardest thing is getting attention. And what we do is we do these podcast videos with some authors. We do launch videos with even more authors, and there will be a launch video that we'll be recording when we're done this, a very brief one. Then we're experimenting with those on social media. One thing that we're doing now, for example, so basically step one, Leanpub can help. It's no guarantee, but we can promote your book on social media. We'll feature it on the homepage, things like that. And we've started doing webinars. And so the first one was on a big article that I wrote about how to market a Leanpub book. And I just talked through it. And then we've got another one that I'll hopefully be publishing later today. And you can find these on YouTube on our webinar playlist that actually walks you through it. And so one thing that you brought up, well, A, do a launch video, B, add chapters over time. This is the sort of heart of Leanpub, is lean publishing, is like publishing in progress. because that way, with that point you brought up with social media is excellent. It's not just that the algorithms, it's like people will be like, you've already announced this book. You've already announced this book. But if the announcement is there's a new chapter that I've added, that's the key there, is that you can do, in a sense, multiple launches of your book. And if it's and on Leanpub, you can actually email your current readers if they're signed up for that. And so the multiple chapters, adding those over time, opting into Leanpub sales, which you can do on the pricing page for your book. And I go through all this in the webinar and the article, and I'll link to it, et cetera. But opting into the sales is actually really important, because those go out potentially. When you're opted in, you can potentially have your book included on a sale in our monthly and weekly newsletter sales. So the weekly one, I think, is over 30,000 subscribers, and the monthly one is over 40, I think, now.
Okay.
And those are all people who've opted in to sort of hear about Leanpub ebook discounts, basically. Another thing, you've already done it, but like reaching out to conferences with with Leanpub, you can create these coupons so that you can work out various ways of doing it. But that's really important. Also remembering that like most people haven't heard of it. Every day you wake up, most people haven't heard of my book. Most people haven't heard of my book. Tweets are quite ephemeral and things like that. And sort of keeping that in mind as well. Another thing is recording your own video about your book or about your new release of your chapter and stuff like that. So one thing that I've only learned about how to do relatively recently is shorts. I don't know if you've heard of this on YouTube. If you upload a video that's less than a minute, it gets called a short. And so what we've been doing is we've been going back over our previously recorded video podcasts and running them through an AI system called Opus Clips that creates shorts. And then you can upload those to YouTube, and some of them get 0 and some of them get thousands of views. And so that, and TikTok and all that kind of stuff. The biggest thing is set aside 15 minutes a day to do something. Record a 1-minute video of yourself talking about your book, something like that, because it's not going to happen on its own. But check out our webinar, check out the article, explore Leanpub for the various things that you can do. But basically the number one thing, set a timer. For the next 15 minutes, I'm going to do something about promoting my book. That could be writing one email to one person, and adding a free, for example, if they're an influencer of some kind, give them a free copy of your book. It's not a lost sale for anyone listening. And people like it. Asking for testimonials, which I know you've done, that's very important. Don't be shy about that. Find the most high profile person you can contact, or the person you admire the most in your area. Ask them for a testimonial. Then be polite. Customize your message, and things like that. But yeah, basically set aside 15 minutes a day. I'm going to do something for those 15 minutes. It might be tweeting. It might be writing a little blog post. It might even be just here's an excerpt from my chapter, and paste a couple paragraphs into something. Just do something every day. And from what I understand, in particular, LinkedIn likes regularity, and so does YouTube, I think. So if you're every day at 10 p.m., I'm going to post something about my book. I think that kind of thing can help. So regularity is really important. Dave Farley, so he's got a book on Leanpub. I don't want to call him a Leanpub author, because he's written one of the most best-selling programming books of all time that was published on Leanpub. But he developed, along with his wife and son, a very successful YouTube channel. And one of the keys to their success was every Wednesday, 7 p.m. UK time, a new episode comes out. So that's just a little trick, is that regularity seems to be rewarded by algorithms. But yeah, 15 minutes a day, explore Leanpub and the opportunities that the options we give you. Don't be afraid to give free copies away, things like that.
Yep. Cool.
Awesome. Okay. Well, Barry, thank you very much for taking some time out of your evening in Milan. You're in a hotel, doing some teaching and stuff like that. And thank you very much for using Leanpub as the platform for your really amazing book.
Yeah. Cheers. Thank you.